Hello everyone. In this video we're going to be looking at the combined gas law. There are two versions of the combined gas law, and the first version is that pressure times volume over temperature equals a constant. We're going to use this version when we see a problem along the lines of the three examples that we're going to go over that are shown here, where one of those three quantities, pressure, volume, and temperature, is being changed, a second one is remaining the same, and we're being asked to figure out whether the third quantity increases or decreases. So in our first example, the pressure is decreasing while the volume remains the same, and we want to discover whether the temperature increases or decreases. So again, we're thinking about this first version of the combined gas law, that P times V over T is a constant. One way of thinking about what that means is that the ratio of the numerator, pressure times volume, to the denominator, temperature, has to stay the same. So here, pressure is decreasing while volume remains the same. Putting that together, that means that the numerator decreases. The volume remains the same, the pressure has gone down, so their product must go down also. That means that the temperature in the denominator must also decrease to keep that ratio of PV to T constant. And so since the denominator must also decrease here, that means that the temperature decreases. In another example, we have the volume decreasing while the temperature remains the same. We want to know what happens to the pressure. Does the pressure increase or decrease? So we're starting from this idea that PV over T is a constant. Here, T in the denominator stays the same. But if the denominator is staying the same, that means the numerator must also stay the same. But the numerator is pressure times volume, and we know the volume is decreasing. And so the only way that the product of P and V can stay the same if V is decreasing is if P is increasing. And so this means that the pressure increases. And the final example that we're going to look at here, the temperature increases while the pressure remains the same, and we want to know if volume increases or decreases. So if the temperature increases, that means that the denominator increases. For PV over T to be constant, that means the numerator must also increase. So pressure times volume is increasing, but we know the pressure is staying the same, so the only way that P times V can increase is if the volume increases. The second version of the combined gas law states that P1 V1 over T1 equals P2 V2 over T2. And so, similar to the first version, we're dealing with a situation where a couple of these, at least two of these quantities are changing, Over here, we're going to use the second version whenever we have quantitative information about the pressure, volume, and or temperature that we're dealing with. An example of a problem using the second version of the combined gas law is shown here. We have a 24-liter sample of a gas at fixed mass and constant temperature, exerting a pressure of 3.0 atmospheres. And we want to find what pressure the gas will exert if the volume is changed to 16 liters. The fact that the gas has fixed mass just means that the number of moles of the gas is staying the same, and so the combined gas law applies. So here we have quantitative information. We have numbers attached to some of these things, so we're going to use the second version of the ideal gas law. So we have P1 V1 over T1 equals P2 V2 over T2. As we discussed in the video on the ideal gas law, typically it's going to be a good idea to write down everything that we know and what we're trying to find. So our original state of the gas, the volume was 24 liters, so V1 equals 24 liters, and the pressure, P1, is 3.0 atmospheres. The volume is changed to 16 liters, so that's V2, and we're trying to find the new pressure, P2. And notice, we haven't been told what the temperature is, but we do know that it's the same. And so T1 is equal to T2. What that means, since T1 and T2 are the same, they will cancel out of the combined gas law, right? No matter what value T1 and T2 have, since it's the same, the denominator on both sides of the equation is the same, and we can just cancel those out. And so now we're left with just P1 V1 equals P2 V2. We're looking to solve for P2, so divide both sides by V2. And so P2 equals P1 V1 over V2, or plugging in the values that we've been given, we have 3.0 atmospheres times 24 liters all over 16 liters. Liters over liters cancels. We have 2 sig figs in all of our values that we're multiplying and dividing, so our answer will have 2 sig figs as well. And so we'll get a pressure P2 of 4.5 atmospheres.